The overall goal of this method is to study the phase behavior of oil samples under refining process conditions by in situ visualization of liquid samples at high temperature and pressure using cross-polarized reflection microscopy.
This method provides a means of investigating the fouling behavior of oil samples under visbreaking and high conversion conditions, and studying how stability is related to conversion. We can investigate severe process conditions since the reactor was designed to withstand 160 bars of pressure at 450 Celsius. In this technique, a stainless steel reactor with a sapphire window at the bottom is illuminated by cross-polarized light, which gives high contrast images of both isotropic and anisotropic media.
First, clamp the microreactor vertically upside down with the bottom face seal open. Ensure that the gas line fittings are closed to prevent the sample from spilling when it is loaded. Weigh a subsample of oil and a thin spatula. Then, use the spatula to load approximately 0.6 grams of the oil sample into the reactor. Weigh the subsample container and spatula again to determine the amount of sample loaded. Then, slide a custom-machined magnet onto the thermocouple. Slide a 1/16 inch front ferrule over the thermocouple into the fitting cavity with the wider side facing up. Dip a cotton swab in toluene, ensuring that the swab is not dripping wet. Wipe the fitting groove and other sealing surfaces to remove contamination from sample loading, being careful not to drip toluene into the reactor cavity. Once wiping the sealing surfaces leaves no sample traces on the swab, allow the sealing surfaces to air dry.